Hi, everyone. Welcome to the session, Securing the Digital Factory. So having worked with different manufacturers over the last several years, both from an Industry 4.0 based manufacturing environments to those that were going through digital transformation and completely changing how they operated to an Industry 4.0 environment, I'll be sharing some of my experience and observation. So whether you are a security leader, architect, professional engineer, or an executive joining this session, I hope this will equip you with some critical insights into 3.0, 3.0 and 4.0 security challenges. What I've done is divided the session into three sections. The first part, I'll talk about some experience and observation from the field across manufacturing environments. And then part two, key concepts around digital factory and my understanding on these concepts. A little disclaimer on this section. I didn't invent any of these concepts. I wish I was that smart. And then part three, I'll be concluding the session with highlighting the framework or approach or methodology I've used to help craft OT security roadmaps for manufacturing organization. And that's about what I could do on my own. So we'll uncover why the old cyber physical playbook fails and what strategic new playbook ensures future success for manufacturing businesses, with some strategic steps that are essential to securing the future digital factories. I promise not to talk about industrial revolutions, survey statistics, any rundown on ransomware attacks. We hear too much of that, but rather just simple sharing. In the end, I would love to get your feedback on what you guys are all seeing in your environment or in your regions in terms of how things are evolving around your manufacturing environment. So let's dive in. But a bit about myself. My name is Yousuf, Faisal, founder of Securing Things, which is an independent IT/OT cybersecurity advisory and consulting firm. I'm bringing in more than 2+ decades from the field. I started my career at an asset owner organization and then slowly transitioned my career into consulting advisory roles, which is most part of my career. And prior to this role, independent consulting business, I've held consulting practice across the region in APAC, leading several global professional managed security services engagement. I run a weekly newsletter by the name of Securing Things by Yousuf, and this presentation is part of a mini course called IT/OT SciSeed. It's like a cybersecurity education and awareness transformation as part of another academy initiative. So enough about myself. Let's dive in. So from all the manufacturers that I've worked for, I can divide them into three categories of most common types, each at different stage of IT/OT cybersecurity or digital transformation maturity journey. The manufacturer A is an Industry 3.0 type environment, which is traditionally led by an IT CISO organization. Their usual focus was on perimeter security compliance, little exposure to IoT or cloud technologies. Whereas in manufacturer B, another Industry 3.0 operation with some IoT deployments, they work usually with IT/OT teams together, especially after a particular ransomware sort of an incident, which forced them to rethink their approach and break those silos between the team. This crisis type of scenarios becomes catalyst for change within their environment. These type of organizations, typically large ones with many plants across all the continents, usually run by a new role called OT CISO organization. And then the third type of manufacturer, which is already on the journey of moving their environment from 3.0 to 4.0. It was led by typical roles like chief digital officer or CIO or CTO. Their vision was a fully connected digital factory, leveraging a concept called UNS, which I'm going to talk about later, IoT, real-time insights, automation, and going through this transformation journey. And then in contrast to these three types of manufacturer, it was interesting to note that they all had similar challenges we have come to read about in many different industry stats, threat reports, or surveys. So each of these manufacturers wanted to identify their current state at the starting point, which in most cases were ad hoc efforts, no defined strategy, and an unmanaged risk state. And they wanted to strive towards achieving a future state of a resilient and secure business environment for a managed risk state. Most of these leaders weren't sure where to start or having internal debates about what should be prioritized on the roadmap. As from previous slide, you can imagine each had a completely different scenario, different type of manufacturing environment, different systems, OEMs, processes, especially culture, skill sets, and so on. So after identifying their current state through initial discovery, with all challenges highlighted on the upper left-hand corner of your screen, and many more like that, the only likely suggestion for these asset owners was to consider their current state as assumed compromise. Obviously, type B was already dealing with a compromise situation. And the recommendations were to stop the immediate bleed and then look at long-term health treatment plans for their cybersecurity journey. And then we'll talk about those in part 3 of this session. So we are going to quickly switch to some of the key differences into these environments in terms of the way they operated. But before we continue, just a quick poll, please. How familiar are you with this concepts of Industry 4.0, digital transformation, UNS, and the digital factory? So before you select any of these choices, think if you have just heard about these concepts in theory, or if you have seen it in real implementations, and whether you have been part of architecting or securing such environments. So let's see the poll results in a few seconds, hopefully. All right. So most of you, 45% of you said that they are slightly familiar, and then 18%, oh, there's 9% or 8% of you that are experts, so fantastic. All right, so I'm going to quickly jump through some of these concepts. So from an Industry 3.0 environment perspective, it was all about automation of manufacturing process that created some digital data. Then came in IIoT, or industrial IoT, that created the ecosystem, providing opportunity to digitally transform the legacy manufacturing business to a business filled with smart connected things. And that led to digital transformation initiatives that was all about moving from manual processes or paper-based processes to an integrated digital processes. It was all about transforming the way manufacturers operate their business by leveraging data they generated every day previously, but never or rarely consume it in real time. So if it's transforming the way manufacturers operate their business, shouldn't we as security professionals be transforming our security strategy accordingly? So from an Industry 4.0 perspective, digital integration and automation of business processes created the information. It's data with context that could be made actionable for your actionable intelligence. So every manufacturing environment you look at goes through a similar manufacturing process life cycle, which is highlighted on the right-hand side of your screen. Since you guys are familiar, so I'm going to skip this part. I'm just going to mention a few facts on the left-hand side of the screen, which highlights 6 layers of automation stack for ISA 95 Part 2, which is a functional model. In 3.0 era, we used a hierarchical point-to-point integration approach to connect and integrate systems like PLC to SCADA, SCADA to MES, MES to ERP. And we were good at isolating machine controls from the internet connections for security purposes. However, it led to complex integration challenges. Each system had unique protocols and data formats to deal with, requiring costly custom connections to be built. They were tightly coupled, Making changes were difficult. So if you have end of life of something, you need to rebuild the whole thing again. Data transformation was slow, hindering real-time decision making, and the architecture didn't scale, which caused data silos and fragmented visibility within your environment. And this slowed down innovation and was costly and limited agility. And industry as a whole have seen attacks and risk being exploited at almost every layer of this automation stack. So moving on to Industry 4.0, the digital transformation initiatives were business driven to solve the Industry 3.0 challenges that we discussed in the previous slide. Unlike your legacy 3.0 organization, a 4.0 organization is a fully integrated business made up of digital factory or factories, where everything and everyone is connected to the network. The layers of the business are integrated and operate based on data and information from every other layer in real time. The stakeholders around this know the current and future state of the business in real time, and it leverages AI, machine learning to collect and analyze data information, where machine learning predicts future outcomes based on past patterns and the current state. And then the AI recommends the operational adjustments to improve the future outcomes. And stakeholders can execute or decide not to execute based on that recommended operational adjustments. Obviously, there were security concerns with such an environment, and it seems to expand the attack surface with this connected devices across all layers of automation stack. So instead of building point-to-point integration, which seems more difficult to manage and scale, a new hub and spoke type of architecture was developed and termed as UNS, Unified Namespace, using some sort of a broker technology and an edge-driven architecture. So with this foundation, let's explore the 4.0 UNS and IIoT and the challenges that comes with it. So what is unified namespace? It's a combination of hardware, software, and master data model. It's a single source of truth for all data and information for your business across all nodes and ecosystem within the factory. It's the structure of your business and all events within that environment. It's a place where the current state of your business lives. It's a hub through which the smart things in the business communicate with each other, and the architectural foundation for Industry 4.0 or digital transformation initiative. So all digital solutions that will be built in future will be built as an extension to the business. That's why UNS is quite critical. It enables real-time communication between IT and OT systems and helping break down data silos. It facilitates the data exchange from production lines to enterprise level systems for improved decision making with unified access to data analytics and insight. And if we use software terminology to explain UNS, it has three components essentially: a UI through which people can input or extract information, an API to retrieve data from the backend system and put it into the UI or vice versa, and the backend system itself, like this SQL database, for example. So this combination of API, backend, master data models that provides a common infrastructure is essentially the UNS. So this is the next evolution, building on the ISA 95 foundation, but cutting down the middleman, the many point-to-point links, replacing the rigid hierarchy, using this master data model to standardize the naming convention and data repository for prioritize information exchange, which is accessible by all stakeholders and devices. The data and information in the UNS is organized to reflect business and its business purposes, and it's organized in like a folder-like structure, hence why the symbolic representation of the folder, enterprise, site, line, area, cell. So what comes with it is that we are providing data out of the factory floor to a lot more use cases, to a lot more business professionals within the company, as well as maybe to your suppliers and customers. maybe R&D department, quality, asset management, supply chain, various project management functions. They're trying to reduce some sort of power consumption or regulatory requirements to be addressed. Essentially, all the business functions that never had access to real-time data from the factory floor now have access to that real-time information. So how does it works? It's all the smart things in the business communicate with one another via a common IIoT protocol, like, for example, MQTT, leveraging some sort of a standard technical, minimum technical requirements. Data that originates from a smart thing, like, for example, maybe your legacy device that does not support this minimum technical requirement, must be integrated via a gateway solution that converts the old protocol and standard that this thing does support to the protocol and standard that the organization has adopted, like MQTT, for example. And then the smart things in your organization publishes updates as they happen to a predefined location within the unified namespace on like the folder structure. Remember that. And then they are configured with smart thing plugged into this ecosystem. So it's like a publish subscribe model that enables devices to publish data to relevant topics, and the systems subscribe only to that data they need. And all the assets that are producer or consumer of the data are treated as a node in the overall ecosystem. So what this approach did was it reduces unnecessary data traffic on your network. It accelerates the data flow and simplifies the system changes because components are loosely coupled. So you can bring in the device and then you can take out the device without disrupting the entire infrastructure. It's real-time, organization-wide data access from plant floor to executives. So think of it as like a fabric. It's just like a distributed architecture, can be designed horizontally or vertically distributed. The architecture is achieved, the distributed architecture is achieved with bridging horizontal publishing and then store and forward from the edge. And the architecture can be designed to avoid any single point of failure for that matter. Understanding the limitations for 3.0, UNS is critical for designing secure, digital, and agile factories. And about the way in this new architecture that data is acquired and transformed into information. It has fundamentally shifted, both from an integration technology as well as from a standardization of the information model point of view. And it goes through an iterative cycle to explain how this data flow is changed, is architected in this new model. I've illustrated this on the slide to explain you how physical machine data goes through the cycle to become actionable information in the digital world for the business. The data flows through following stages. It's connect, where we interface different devices, sensors, and convert. Then we collect, we use protocols and message broker technology that supports open architecture. It's lightweight and report by exception. Then we have store and normalize to standardize and add context to the machine data, and we store it. Then we analyze and visualize that information and find patterns to report and solve the business problems. This is where how OT data meets IT style data governance and security control. So have you ever wondered why you keep on hearing IT and OT are converging, though used overrated and misinterpreted in most situations, but I hope it gives you an idea why it's been said like that. So securing the data life cycle becomes a very important aspect in the 4.0 environment. So the next question to tackle is what to do with designing and securing such network architecture. Which reference architecture to follow, or simply rely on the 4.0 solution architects to suggest and then try to secure it. So looked at Purdue model, which is probably a no-go in this scenario. And various organizations have proposed new industrialized models such as Internet Industrial Internet Reference Architecture, the RAMI 4.0, ISA zones and conduits type, which is definitely could be applied in this context. These models are broad in scope. They describe architectural concepts and viewpoints and stakeholders and relationship, but they do not describe a specific solution architecture per se. So there was a recent publication last year by ISA Secure, I believe, on the IIoT system implementation certification. I highly recommend you go and read. It clarifies some of those unknowns, and it's well documented. It's not defining the architecture per se in detail, but at least you have some basis. And last but not the least, one of the best things I've seen is like the IT OT reference architecture, which is event-centric. It's a paper published by Paul DiBiase in July 2023. It's a reference architecture for integrating OT and modern IT, where he declared that Purdue is obsolete, a significant change in Gartner's decade-old position, and this represents the next step in the evolution of the Purdue model towards a distributed, interconnected model. And the recommendation in that document is that you need to move towards an event-centric or event-driven, I would say, architecture, where you have cyber-physical security platforms working to protect your OT environments as well. So regardless of whether they were 3.0 or 4.0, they had similar issues around network architecture. In my experience, most of them, when they start their journey, had flat network, direct access from the internet, or devices in the OT environment could reach to the internet. I've seen PLCs dual home between IT and OT environments, varying types of remote access connections, uncontrolled mostly, no DMZ in between IT and OT, direct wireless access, and so on. So these and many more need to be fixed as part of your cybersecurity program journey. So back to those three typical manufacturers we talk about, I needed to adopt some sort of a framework and methodology whereby I could address the requests from those asset owners and follow something that is not specifically against a specific standard, but rather to ensure that the program provides maturity and essentially leads to compliance with these standards in the future timeframe. So I came up with this 12 foundational step to almost 3 years now ago. I call it the OT security dozen at the time. Now I'm calling it IT and OT security dozen, because your manufacturing depends on the entire life cycle that we talked about. It involves both IT systems and OT systems. So I've divided this 12 steps in 3 buckets. Basically, bucket number 1, securing the business, where we talk about the reviews, discovery, the policy, governance, risk, compliance, etc. Then you have second bucket for security controls implementation, where you have network, asset, remote access, and all that. And then last but not the least, the secure operations for your business. So where you monitor, measure, and maintain your environment. So under this framework, the approach I took was factoring in overall aspects of the business, who the stakeholders involved are, what is the relevant organizational context in terms of the organizational hierarchy, the decision-making power, things like that, and then the manufacturing lifecycle stages and the physical processes. Then look at the business inventory across each layers of this automation stack, mapping from the namespace model as well, and then looking into OT project lifecycle stages, and then making sure that we embed certain security activities within that lifecycle. So the goal is to essentially identify some sort of a preconditions and objectives, analyze the associated risk, and then drive specific security requirements and design and implement controls or security solution. One thing that's I think often overlooked in OT engagements due to scope and budget consideration is that OT operations often rely on some system in your IT network. But since IT is excluded, they often say, oh, by the way, this is excluded, so we don't need to consider that. But they miss the point. We have Clorox type incidents happening all over the place, where a system compromise in IT could impede the operational environment. So coming back to those three manufacturing organizations, this slide highlights the partial roadmap that I built for the program journey. I divided into the three parts program that I mentioned earlier. Each part have approximately 5 or so goals, totaling around 12 to 15 goals, plus or minus, and then spread over 2 or 3 years down the road. So for 3.0 organization, this was a linear approach. For A and B in this case, but for the ones that were advanced in their journey and had adapted agile methodology, we ran these projects in sprints in parallel by identifying dependencies for the like of manufacturer type C. So many of these initiatives face hurdles from different stakeholders due to lack of commitment or clear ownership, while others made progress where shared values and requirements were agreed and mandated right at the beginning of these initiatives. The common recommendation I had that's not highlighted here is the initiation of 90-day remediation program for quick wins and fixes after doing some sort of an initial discovery and assessment exercise. It didn't require any heavy investment. It turns out that it was reducing the attack surface and risk considerably. So now from an industry 4.0 environment, beside some of these program elements highlighted on your screen, 2 key things are going to become crucially important. Coming back to our data flow, the data security aspects of things. So if we talk about this, then at the bottom of the screen, you can see that I'm highlighting some of the things that we are concerned with from a security perspective. So at the connect and collect stage, we need to ensure using secure methods for connectivity and collection, using secure protocols, encryption, certified connections, maybe PKI, and all that to mitigate any security concerns. You can adopt DDoS prevention strategies by authenticating all new connections to the broker. And then the store and visualize layer, we can move towards, is it time, Jonathan, or I'm for now? Not looking at the time.
Yeah, you have 3 or 4 minutes still.
All right. So I'm just finishing. So for store, analyze, and visualize stage, we are more concerned with data classification, governance, access control, and protection, both at rest and motion. And then at the finding data patterns and reporting stage, we are concerned about the same things which we do in a traditional on-prem environment, but we are also concerned with, in addition to that, the security around cloud and AI. So it's going to become an increase important from a data governance point of view as we move on to 4.0 environments. Beside data security, human identities and NHI identities exist at each layer of automation stack, from cloud to factory floor. So the identity solution which is prevalent across IT or cloud environment, are also going to become essential security controls across your OT network stack as well. So the ultimate goal is to ensure business is business inventory is documented along with manufacturing workflows. Your assets or crown jewels are identified and their risk maturity understood. You have a secure network reference architecture, an appropriate set of controls that you have identified across the stack based on some industry best practices like 62443. And then overall, as an outcome is to build a layer defense model, which is a defense in depth approach to slow down malicious attackers in order to respond to them effectively. So that's about it. Thank you. And please feel free to reach out or ask question. And I hope you enjoy the rest of the sessions.